Your brain is the most complex object in the known universe. More connections than stars in the Milky Way. Capable of language, imagination, and self-awareness, no other creature has matched. But here's what most people never ask: why? Lions didn't keep getting smarter. Chimpanzees didn't develop language. So what switched on inside the human skull that sent our brains on a growth explosion unlike anything else in evolutionary history? The answer isn't one thing. It's a chain reaction that started not with genius, but with survival. 3 million years ago, our earliest ancestors, Australopithecus, had brains roughly the same size as a modern chimpanzee, around 400 to 550 milliliters. They walked upright, but cognitively, nothing separated them dramatically from other primates. Then something shifted. Between 2 million and 800,000 years ago, brain size began climbing. Analysis of 94 hominin fossil skulls published in the Proceedings of the Royal Society, B, confirmed this gradual march across 13 species over 3 million years. The increase wasn't random. Something was driving it, and it starts with the environment. The Smithsonian Institution's Human Origins program compared two graphs: Earth's climate fluctuations over 3 million years alongside human brain size over the same period. The pattern is striking. Brain size grew fastest during the most extreme climate instability, particularly between 800,000 and 200,000 years ago, when Earth swung violently between ice ages and warm periods. Our ancestors were constantly forced into new territories and new threats. A bigger brain wasn't a luxury. It was the difference between adapting or dying. Brains are expensive. The human brain consumes roughly 25% of the body's total energy. For it to grow, the body needed significantly more fuel. Around 1.8 million years ago, Homo erectus appeared with a larger brain but smaller gut, smaller teeth, and smaller jaws. Harvard anthropologist Richard Wrangham argues this signals a dietary shift. Cooking or processing food unlocked more calories and reduced digestion costs, freeing the energy the expanding brain required. Every calorie not spent on digestion could go toward powering a larger, more capable brain. Tool use became more sophisticated around the same period. Homo habilis, emerging 1.9 million years ago, showed brain expansion alongside the earliest confirmed stone tools. Making tools doesn't just require intelligence, it creates pressure for more of it. Better tools meant better survival, passing slightly larger brains forward. But tools also required teaching, and teaching required social complexity. The more complex the group, the more brain power was needed to track relationships and alliances. Brain growth and social intelligence fed each other in a continuous, accelerating loop. Fossil evidence around 1.9 million years ago shows expansion in Broca's area, the brain region most connected to language production. Not full language yet, but the beginning of its architecture. Language changed everything. Knowledge no longer died with the individual who discovered it. It could be passed on and built upon. A hunter who found a technique could teach it. A healer who identified a plant could describe it. Information became cumulative. Each generation inherited everything the last had learned, rather than starting from zero. The result, a brain approximately 238% larger than expected for a primate of our body size, according to phylogenetic analysis published in PMC. Modern humans average 1,200 to 1,400 milliliters of brain volume compared to roughly 400 in chimpanzees. But size alone doesn't capture it. The prefrontal cortex, responsible for planning, abstract thought, and long-term decision-making, expanded dramatically. We didn't end up with a bigger chimp brain. We ended up with something qualitatively different from anything else that has ever lived on this planet. There was no single moment when humans became intelligent. It was a compounding chain. Climate instability forced adaptation. Better food unlocked energy. Tools demanded sharper thinking, social complexity required more cognitive capacity, and language turned individual knowledge into something that built across generations. Each step made the next one possible. The brain you're using right now is the product of 3 million years of that process. Intelligence was never the goal. It evolved because in a world that kept changing without warning, the creatures that thought faster, learned quicker, and communicated better were simply the ones that survived. And the fact that you can even ask why is the answer.